Another area is in looking at sedimentary content. So this is views in the Colorado Plateau. And you see how nicely striped that is. Well, that's because it's made of sedimentary rock. What's sedimentary rock? Well, believe it or not, this used to be the bottom of the ocean. Long time ago. And what happens in the bottom of the ocean is things fall to the bottom of the ocean. For example, rain. Rain falls on Georgia mountains, and it washes away some of the mountains, and it washes it into the rivers, washes it into the ocean, and the stuff that's been washed off the mountains gets compacted into the ocean. Another thing that happens is when it rains, carbon dioxide in the atmosphere dissolves in the rain. It makes carbonic acid. How many of you have had a Coke or a Pepsi or some other soft drink? Everybody? Kind of makes your tongue tingle, right? You know why it makes your tongue tingle? Because it's got carbonic acid in it, and the acid is eating your tongue. Doesn't eat it very bad, but that's what makes your tongue tingle. It's carbonic acid. In World War II, they put Coke in steel cans and shipped it overseas to our troops. And when they got there, they opened the holes in the ships, and it was full of Coca-Cola sloshing around, because it ate right through the steel. Okay. So think about that. You know, if you drink a lot of Cokes, it's going to take the enamel off your teeth. So, you know, be careful with carbonated drinks, but that's literally carbonic acid. And that washes into the ocean, it falls into the ocean, and that carbonic acid reacts with fish bones and clam shells, and it takes the calcium out of that, and it forms calcium carbonate, which we call limestone. So many of these layers are limestone. That was made from carbon dioxide dissolving in rain and reacting with fish bones and clam shells and things. And it makes limestone. So by going into these sediments, we can determine roughly how old the sediments are, and we can look at things. We can look at biomarker molecules. In other words, we look for specific molecules in there. It gives us an idea of what kind of life forms are going on. Then we can look for fossils of vegetation, animals, plankton. Those are little one-celled things in the ocean. Zooplankton are animals, and phytoplankton are plants. Now, it's pretty easy to tell a dog from an oak tree, but when you're dealing with plankton, sometimes phytoplankton and zooplankton look a lot like each other. And so, looking at the types of plants and animals, we can determine what kind of climate was around. For example, they found fossils of tropical ferns in the Antarctic, and also at Spitsbergen Island, which is far north of Sweden and Norway. Okay, those are not tropical places, but we found tropical plants there. That tells us at one time they must have been tropical. So we can look at the ratio of magnesium and calcium in foraminifera. Is that the right way to pronounce that?
We just call them forams.
Forams? Okay, we'll just call it forams. I always have trouble pronouncing that. And from that, we can reconstruct past temperatures. Those are little one-cell critters that you find. And then the other thing, we can look at those isotope ratios, just like we showed in the last slide, the delta 18 record ice. So by going through these strata, drilling holes through these, we can go down, and what we find there helps us see what was going on. And another thing that we can look at is we can look for sea level rise signatures that fall, such as fossilized sand dunes and things. And of course, when you find whale bones or clam shells or things in places that are not mountains, that tells you a lot. Have you all heard about the Great Salt Lake in Utah? Okay, the Bonneville Salt Flats, that used to be an ocean. That's what's left of an ocean. Most of it is evaporated. So once sea level was that high. So all these things can tell us, give us information about what the climate was like. But you have to be careful with this kind of thing because it's different than directly measuring temperature like we do now. You know, for example, say I want to know how many students there are here at Georgia Tech. Well, one thing I could do is I could just go out and count students. That would be directly measuring the students. But what if we decided it was too difficult to count students? We couldn't do that directly. We'd have to find an indirect way. Well, one thing is that students pretty much all walk around with their cell phone on all the time. Okay? They'll even walk down the street, two friends, and they'll be each talking to somebody else on the cell phone. So maybe one way to count the students would be between when classes stop and the next one starts, is to check the number of cell phone signals that are going to the cell phone towers. And from that, I could make a pretty good guess at the students, because they're going to come on when one class ends, and they're going to, at least if they're in my class, they're going to turn their cell phones off when the class starts, because if I see their cell phone, I throw them out of my lecture. But, so doing that would be a method of indirectly measuring the number of students. Okay. So that's the difference between direct measurement and indirect measurement. And when you do indirect measurements, you can still get error. As a matter of fact, even measuring directly, you can get error. Another way we can do is look at coral. And Dr. Curry showed a picture of our colleague, Dr. Cobb, who actually goes out and does this. Coral rings are similar to tree rings, but they respond to different things. Water temperature, wave action. So certain equipment can be used to derive the sea surface temperature and water salinity over the past centuries. Now, when there's a glaciation period, the salinity of the ocean goes up. That's because salt doesn't evaporate. Okay, so if you have salt water and you evaporate some of the water, the salinity goes up. If you get more rain and you get evaporation, the salinity goes down. So these things, by looking at the coral, can give us indications of what the sea surface or the sea temperature is